So I'm looking on AS Vectors 8.4 exam style questions. So this is 4.1. Both of these exam questions are linked to unit vectors and looking at magnitude and direction of vectors. So we are asked to find the values of A and B to three significant figures for this vector here when it has magnitude 4 and it is going in the same direction as the vector 7i minus 3j. So if we think about what that means, so we've got 7i minus 3j is a vector that looks something like that. So that's 7 across and minus 3 going down. So we know that it's parallel to that. We know that it's going in this direction, and we want it to have length 4. So if we work out the length of this and then work out the unit vector of this, we should be able to work out what this vector is. So that's the first method that we're going to have a look at. So we've got unit vector would be, I want 1 over the magnitude of the vector. Remember, using Pythagoras here is just finding the size of that vector. So this is the size of the vector. If I divide this vector by its size, then I will know what it is as a unit vector. So we get 1 over the square root of 58 times 7i minus 3j. So that's that vector as a unit vector. So I now know this. I want that to have length 4. So I want to work out what that's going to be if it's got length 4. So because we've got magnitude 4, what we can say is that I want 4 lots of this unit vector. So the blue here had length 1. This now, if I multiply it by 4, has length 4, and it is going in exactly the same direction as that. So I'm saying I want 4 lots of that unit vector there. If we calculate this, so just expand that bracket, so 7 times this and minus 3 times this, we end up with A is equal to 3.68 to 3 significant figures, and B is equal to minus 1.58 to 3 significant figures, as asked for in the question. Alternative method here, although possibly makes it slightly harder. But remember, if you're in an exam and you're trying to do problem solving, it's just having a starting point, and it is okay to just start in whatever way you see fit. So if we consider the angle of this vector, remember with vectors, the best thing to do is to get a diagram drawn. So what you can do is set up simultaneous equations, because we know that that angle theta, so tan to the minus 1, which is equal to theta, of 3 over 7, so it's just that triangle there where that's length 3 and then the adjacent there is length 7, has got to be equal to the inverse tan of b over a. Just have a think about that. We've got this vector ai plus bj, which is just a across and bj down, but it has to be in the same direction, and the direction just means that the angle is the same, so we know that it's somewhere here. So it's a similar, we've got similar triangles there, so you could do this using similar triangles. I.e. we didn't need the tan to the minus 1, because what that means is we've got b over a is equal to 3 over 7, which implies that b equals 3a over 7. So you could get to this line just by thinking about similar triangles if you can spot that. But remember, a lot of this is just linking what do I know about this topic, starting, writing something down, and then trying the solution up from that point. The other thing that we know is that the magnitude has length 4. So the magnitude of the vector in question is a squared plus b squared, square rooted, is equal to 4, which leads us to a squared plus b squared equals 16, and then between those two equations you have got simultaneous equations and you should be able to solve those. It would just be a case of just being careful when you square root something. Just remember that that presents you with a plus or a minus case, and that's where the diagram is useful, because we know from this diagram that b needs to be negative and a needs to be positive just because it's going in the same direction as that vector there. So you would need to consider that if you were using this method. But so there's a few different ways to go about it. I think the unit vector one is the easiest one, but if you're just looking at the information in the question, so magnitude and direction is the angle, magnitude is Pythagoras, it might be that you go down this route instead. Excellent. Example 8.4.2. So I've already drawn a diagram to represent this, so just take a moment just to have a look at that. As always with vectors, a diagram is really, really useful. This, if yours hasn't got arrows on, they should all have arrows on the top there, otherwise it doesn't make sense. So we've got the point C lies between A and B, and it's 5 units from A. So let's just change colour so we can see it. So we don't know where C is, but what we do know is that there are 5 units between A and C. O to A is minus 4i plus 5j. Going to write it that way, just it's easier on a diagram. And O to B is 2i minus 3j. So they are position vectors. Position vector is where we go from the origin. Remember, on a coordinate system, that would be the coordinate 0, 0. So that line is just saying we're going from the origin to A and from the origin to B, and then we've just got this vector here, AB. So if we focus on the vector A to B, think about our strategy. I want to work out what O to C is. I know that I can get there by going O to C is equal to O to A plus A to C, or alternatively O to B plus B to C. However, we've been given some information about the distance from A to C, therefore I'm going to stick with this one because I don't know anything about B to C, so we haven't got that information there. So to work that out, if I work out the unit vector of A to B, that will give me one length, and then what I want to do is I want 5 of those lengths in the same direction. So ultimately this is the same question as the one that we've just looked at. Okay, so I want to work out what A to C is, so I'm going to start with A to B. A to B is equal to A to O, which is minus 4, 5, negative, because I'm going in the opposite direction. Remember, minus 4, 5 is O to A, so I want to reverse that. And then I'm going to add on to that O to B. So that's 2 minus 3. So we've got minus 4 minus, so that's going to give me 6 there. And then minus 5 minus 3, which is giving me minus 8 there. So that's the vector A to B. To turn that into a unit vector, we are doing the square root of 6 squared plus 8 squared. Times that. So that gives me, that's going to give me 100 square rooted is 10. So I'm just getting 0.6 minus 0.8. There. Therefore, A to C is equal to 5 lots of that. So we've got 5 lots of 0.6 times minus 0.8 because I want the length to be 5. So that unit vector was just giving me length 1 between A and B. I want it to have length 5, but it's still going in the same direction as A and B. So that gives me 3 minus 4 in terms of that vector there. Therefore, to finish off, to calculate O to C, we are doing O to A, add A to C. The direction should already be worked out just because of the way that we went about this, because I used A to B at that point. So we've got minus 4, 5, add 3 minus 4, which is equal to minus 1, 1. And if we're using the notation that we were given in the question, we would then write that as minus I plus j. And that is the end of that question.